Here is SolidWorks training video number 2, Assemblies and Mates. Okay, so first off, if you have not watched the basic navigation video, I would suggest you start there. Now let's start talking a little bit about assemblies and how to make them. So what we're going to be doing today is, to start off, we're going to build this. We're basically taking this bracket and gluing it to this aluminum beam. So let's do that. If you don't have SolidWorks open, go ahead and open it up. Once in, we're going to click on File, New, and then select Assembly. Now when you click on OK, you may get a prompt asking you about units. I cannot remember at what point during the installation registration process it asked this question. If you get that question, select IPS. If you've already selected something else, don't worry about it. We can address that at a later time. So assembly is selected. I'm going to click on OK. Now, at this point, what is going on? SolidWorks is asking me what part or parts I want to add to this assembly. So, again, our folder structure should have already been set up. I'm going to go underneath SolidWorks Files, Servo City Parts, and I'm going to select this aluminum beam 9-hole. And then I'm going to click on Open. This point, it's asking me to place the part. You'll see over here on the left-hand side, we've got this Begin Assembly dialog started. It's got the part that I've opened over here. Now, as soon as I click and drop the part, that wizard goes away. And now I'm left with my assembly tree. So, one part does not make an assembly. I need to add at least another part. You'll notice up here at the top, when I have assembly selected down here, Insert Components is my second option. So I'm going to select Insert Components. And then the beam I'm looking for, or the bracket, I'm looking for, is this beam bracket B, big 45 degree. Now, notice the way it is oriented. It will be laying flat with my beam. If you remember from the picture I showed you of what we were going to build, that's not the orientation I'm after. Down here is a rotate context toolbar. So right now I've got that, so that's being shown. Hopefully you do as well. This toolbar will allow me to rotate the piece before I place it in the assembly. So if I'm seeing my 3 axes here, this X, Y, and Z says I will be rotating it around that axis. So if I were to grab the Z axis and spin it in my fingers, for instance, I would be twisting this part like that. Similarly, Y would spin it so that it stays flat on the floor, but spins around. What I really want to do is to rotate it once on the X-axis so that it's kind of up and down like that. And then I want to place it. At this point, I have the beam and the bracket in the assembly. I can, with my left click, grab a hold of this bracket and move it around. However, if I try and grab a hold of the beam and move it, I immediately get that message. The selected component is fixed. It cannot be moved. So what this means is the first part that I drop into an assembly is labeled a fixed part, and SolidWorks denotes that over here in my assembly tree by placing an F in parentheses beside the part itself. You'll notice the dash beside the beam bracket, and that means it floats or it can be moved around. So this does mean when we are starting an assembly, we should use a little bit of thought, try and figure out what is our base part, and add that first so that SolidWorks will automatically make that the fixed part. I can change what is fixed and floated inside of an assembly, but we will get to that later in our training. Now, if for whatever reason I do not want a part that I've added into my assembly, it is as simple as clicking in the part and hitting the delete key, or right-clicking and selecting delete from the context menu. At that point, it will give me a confirmation dialog, and I can click on yes. But let's go back in, because we do want that part in there, and we do want it oriented this way. And let's continue. Inside SolidWorks, a mate defines the relationship between two parts or components inside the assembly and how they interact with each other. So what we are going to do is to define a series of coincident mates between this bracket and our aluminum beam so that they are joined together in a manner that we looked at before. So first thing we need to know is, how do we select various properties of our parts? So if you'll look, when we hover over top of a part, whatever feature we're hovered over top of gets an outline around it. And then when we click using the standard left click on a feature, that feature is now highlighted in blue. So we can select a face like I did here. We can select a curved face. This is still a face. We can select an edge. We can select the edge of a cylinder. We can select the edge inside this elbow like this. So at any point, we can click on various features and select them. Why is this important? Because we will be selecting the features as part of our mating. So what we're going to do right now is to make it so that this face and this back face of our bracket are joined together. So we click on mate. I'm going to pre-select coincident as our mate type. When I click on this first face on the beam, you'll notice that a reference to that face comes over here in our mate selections box, and also that entire part becomes transparent. Now I must select a feature on a different part in my assembly. So I'm going to come around again and select this back face of my bracket. Now a reference to that face has been added to my mate selections box. And when I click on OK, which is the green check box, that mate has now been defined. Now that this mate is defined, I can still move my bracket around. I can slide it up and down. I can move it so that it's no longer touching this edge. But throughout all of that, those two pieces still have those faces sharing a plane. And that's what coincident means. Not that they're physically touching, but that the two features that were selected will now share a plane. Knowing that this bracket can still move around quite a bit, I know that I need more mates. So what we want to do is to line up this edge, this elbow edge, with the bottom face of our beam. So again, I'm going to go into the mate property pages, but this time, instead of selecting a face on my bracket, I will select this edge. I'm still going to be using the coincident mate though, and I'm going to select the bottom face of my beam. Now when I click OK, those two are now lined up, sharing a plane. I can still rotate the bracket, but no matter what I do, those two relationships that I've defined between these two faces, and now this edge and the bottom face of my beam, those two relationships will never be broken. Again, I can make it so that they're not touching. This edge still shares the same plane with the bottom of my beam, even though they're not actually physically touching. Physically touching is not a requirement for a coincident mate. The only thing that is required is that they will continue to share the same plane. Let's add one more mate. Let's put this edge coincident with the back face of our bracket. Select mate. Select this edge. And select this back face. Notice I did not select coincident, but now it is selected. SolidWorks saw the two features I had selected and chose the most likely of the mates that were available. So again, I'm going to click the green checkbox, and the part looks like, or the assembly looks like, the original thing we said we were trying to build. Now, can I move that bracket? I try, and I get that message. The selected component is fully defined. It cannot be moved. So we know now we have a fully defined piece, or a fully defined assembly, in that these two pieces will be moved together. An interesting question at this point is, what would happen if I tried to add an additional mate? So let's say I try and add a mate that would line up this face of my bracket with this edge of my beam. I'm going to select coincident mate and then select that edge. Notice it did not move to satisfy that mate like it did previously at this point. I click OK, and I'm now getting this message. SolidWorks is basically telling me you've got an anomaly, or to make this happen, I'm going to have to break something else that you've told me to do. We can click on OK and allow this to go through, but at that point, SolidWorks will tell us about our errors until we resolve the conflict. So I'm going to cancel and leave things the way they are. Now that we have those three mates defined in our assembly, we can actually find them in our design tree. So if you look at the bottom of the design tree, you'll see mates, and you'll see this triangle pointing in. That's an indication that, of course, this can be expanded. We click that and it points down now, and we can see the three mates that we have defined. If I hover over top of a mate, what you will see is in the 3D model, the two features that are used inside that mate are now highlighted. So that is an interesting way, and if I click on it, it is highlighted a little bit differently. So that is an interesting way so that you can see what comprises your individual mates. Also, now that I have found these mates, I can easily delete one. So if I highlight the last one that we made, I can either click on my delete key on my keyboard, or I can right click on it, which will bring up this context menu, and I can click on the delete button. SolidWorks will give me a confirmation dialog. Now I'll say yes. Now I'm back to being able to move my beam around because that last mate is no longer active. Let's define that mate that I couldn't define earlier, meaning this face with this edge. But we're going to do one thing a little bit differently this time. If I select this face first, then I click on mate, you'll notice that that face has already been pre-populated into my mate selections box. For some reason, I like to do this a lot. It just feels right to me. So now I'll go in and select the coincident mate, select that edge, there we go, and hit the green OK. And again, I now have a fully defined part that cannot be moved. You might have noticed 3 is kind of a magic number. We have 3-dimensional space, and it usually takes 3 coincident mates to lock down a piece. If you have been following along in your own copy of SolidWorks, feel free to close this out and do not save this assembly. We will not be using it for any additional training. At this point, I'd like to talk to you about the pin in the Property Manager. If I go in and create a new assembly, select a part, you'll see the Property Manager window is open over here. Once I drop the part, that disappears. That is something I can control to a certain extent. If I bring up the Insert Components again, select a part, and click on this pin, you'll see this pin says Keep Visible. This is saying to keep this Property Manager window, Insert Component, keep it visible. So even when I drop a piece, it's still visible, and I can drop that same piece again. I can go Browse, get a different piece, select that other piece and drop that instead. I can now click the green check or the red X to indicate I'm done. And honestly, at this point, it does not seem to matter. Either way, those parts that I've already dropped are in my assembly. Unfortunately, SolidWorks does not remember that pin setting. I've brought up Insert Components again and selected a part, and you will see the pin is not selected, and I drop this part and my property manager page goes away. One additional interesting feature about this, and I'm going to delete all of my objects. If I go into Insert Components and I have multiple parts selected and they're still all highlighted or selected over here in the Insert Component Property Manager page, it will allow me to drop each one of those in succession. And you can see my list is slowly shrinking as I drop each part. And then when I drop the last part, now that property manager will go away. On the other hand, when I select Mate, the Keep Visible pin for me was pressed by default upon installation, and I believe it will be that way for you too. And this one gets remembered. So right now, if I want to set up a mate between these two beams and save it, this stays active, so I can create a second mate and a third mate and a fourth mate and so on. And when I'm done, again, it does not matter whether I cancel or whether I click on OK. At this point, it will clear and the mates that I have created will still remain in the document. So if I go into the mate and I click on that pin to uncheck it, create some mate, now that goes away as soon as I click the green OK, and the next time that I go into the mate, it is not pressed. The Keep Visible is not selected. So the mate, unlike my Insert Component, remembers my pin. Coincident mates really are not going to get us very far. Most of what we want to do inside SolidWorks with our Servo City parts will require us to line up screw holes. So for right now, we are going to bring in a aluminum beam 9-hole and a beam bracket type E, which is an L shape. We're going to bring in those. I am going to pin this because we're going to lay down one beam this way. We're going to rotate around our y-axis and lay the second beam down perpendicular because we are going to attach them with our L bracket. So we want to rotate this. Let's see. So that it's that way. And do that again. And those are the components we're going to use for this assembly. Now we will start with our coincident mates because we know that when we use the screw holes and put these things together, we are going to be putting faces together at the same time. So let's go ahead and make our coincident mates that are needed. There's one, and I'm going to pin it because I'm going to make mate after mate after mate. And it should be 4 total. I can't get to the bottom of that beam. There we go. Okay, so now we have our coincident mates. But what we're really trying to do is to build this right here so that we've got our holes lined up. To line up holes inside SolidWorks is called the concentric mate. So if I select the concentric mate and then select a face, it's going to tell me the selected entity is not valid for the current mate type. That's a good thing, and we'll see more of that later. But I want to select this hole. I could have also selected the rim around the hole, but I'm actually selecting the inner face of the hole itself. And then saying OK. Now, like we've done in the past, what does that mean and what does it not mean? Well, we've got these 2 faces with a coincident mate, and I've got this hole lined up with the concentric mate. But that's just one hole. Right now, this part will freely rotate around that hole. So again, a 3rd mate is required to lock down that part. So we'll go ahead and create another concentric mate. And now this part has been locked down. Select component is fully defined. It cannot be moved. Remember before, when I selected 2 faces, SolidWorks automatically selected the coincident mate. SolidWorks will do a similar thing if I select 2 circular components. So right now nothing is selected over here. I select my 2 faces and it lines them up and automatically selects the concentric mate. Now I'm going to flip my assembly over so that I can more easily get to the mates that are required for my other bracket. One other thing I want you to notice is that when I have a fully defined mate, I have the checkbox over here, which is what I've been using this whole time. I've also got a green check here, Add Finish Mate, and a green checkbox over here in the upper right hand corner. Any one of those green checkboxes will do the same. In fact, the one that pops up right here is very close to the action and makes it very easy to find and get to. And I don't know why it didn't. It's wanting me to select the mate type. Okay, so I now have my 2 beams held together by the 2 brackets. But there's no screws actually holding them together. It's only defined that way in SolidWorks. If I am doing some prototyping where I'm trying to prove out a concept, this is acceptable. But for a final design, we really need to make sure those screws are in place. The most important reason being, I'm if I'm going to have moving components on my robot, I may not allow for the clearance of those screws. This actually happened to us this past season during a design where we had a design in place and then had to modify the design on the fly because the screws were not defined in SolidWorks. So let's add the screws and the nuts to finish this up. So I'm going to go into Insert Components. My screws and my nuts are underneath machine screws. So I started typing in the word machine and it jumped to those parts in my file list. I'm looking for the 632. So this is a number 6 screw with 32 threads per inch. This is the nylock nut. So this is the nut that we're going to need. And I'm going to select I believe that's 5/16. No, a 7/16 length screw. So I am again going to keep this visible. I'm going to put my 4 nuts in place. And I'm just going to drop 1 screw in for right now. And I'll show you why in a few minutes. Now we're going to put all of our nuts along the top. And I want to show you a cool feature inside SolidWorks that makes this a lot easier. Since all 4 of my nuts are all going to be lining up on the top of this beam bracket, I can select the beam bracket, the face that I want, and then click on this little lightning bolt paperclip, multi-mate mode. When I click on that, I have told SolidWorks I am going to mate multiple parts to this one common mate entity. So now that that's selected, I'll roll my assembly over so that I can see the bottoms of my nuts, and I will select this face on each one of them. And just like that, all 4 of those mates are defined. You will notice down here, or even when I click the checkbox and open up my mates, that has created 4 separate mates for me. Now I will go through quickly and line up a concentric mate with this hole on each one of my nuts. So each nut will be on a separate hole. It's really not all that important which circular face on the nut that you use, as long as you can find one. You can use this one on the inside there. That will line us up just fine. You can use this face right there. That lines us up just fine. So any of the circular parts on the nut that are circular to the middle of the nut will line us up properly. And that's done. Now we need to put our screws in place. Remember, I only brought 1 screw in here, and that was on purpose, because I wanted to show you that the 0.625 screw is too small. It does not go quite to the end. We can see here I've got it lined up. The shoulder of the screw is lined up with the bottom beam bracket, and the screw head just does not quite make it to the top of our nylock nut. That's going to be a problem because the locking part of the nylock nut is right here at the end, and this just is not going to grab and give us a good lock. So we need to go grab some 0.75 inch screws instead. We'll select this, we'll delete it, and go into the insert components, go back into our machine screws, and find the 0.75 inch machine screw. Now you'll notice when I bring the machine screw in, obviously I have to go through some of the rotate in order to get this thing oriented correctly. And I'm having to click on that X 3 times. I'm just going to drop one screw in at this point instead of dropping in 4. And now when I click on that part, Control C copies that part, and Control V will paste a new one in. Nice quick trick when you are dropping multiple parts in a orientation that requires you to use that rotate context menu. Just drop one in and then you can use the copy and paste. Again, that was select the component, use Control C to copy, and then Control V to place. And you'll notice when I did the Control V, I'm going to delete a few of these. I'll delete all the ones that I added. When I hit the Control V, it adds at the place where my mouse is at. So kind of gives you an opportunity to spread them out or put them where they need to go. Again, we're going to go into the mate and use the multi-mate context. We want the shoulder of all of our screws, so this shoulder right there, to be lined up with this face of our bracket. So we select that first. We make sure that that's up in the top, and that is our common mate entity. Then we will select the shoulder of each one of our screws. And now that that is done, the easiest edge on our screw to get for that concentric mate is this outer edge right here. But notice I am still in multi-mate selection. I want to get back into single mate mode. So I click that again and that puts me back into single mate mode. Now I can select that circular face, that face, and get all of my screws in their final location. And there we go. There you have it. Again, this is not something we're going to continue to work with, so if you followed along in your own SolidWorks, feel free to X out of this. You can save it if you want, but feel free to throw it away. Okay, let's give you a little bit of an assignment here, something that you can work on. I'm wanting you to build a assembly that looks like this. So this is very similar to the chassis that we used this past year for our robot Black Arrow. And I want you to put something like this together using screws and the brackets and everything that's necessary. So let's look at what is required. What are the parts that you need? Here's those parts. So this is a channel, 10.5 inch. That's the two that are in the middle are the channel 10.5 inch. The two on either side is the channel 16.5 inch. And these are pattern mounts. So I started them with the letters PM, and they are side tapped pattern mount type C. So side PM, side tapped pattern mount C. So if we look closely at these pattern mounts, we're going to see that they have tapped holes. So the holes along the side, a lot of these holes on the face, they have threads. That means that we do not need to use nuts. We just need the screws to go into these threads. It also, though, presents us with many different faces that we can select, or many different features we can select for the concentric mate. We do, however, have to be careful. There is one or two features inside that hole that if you try and select them, they will not make a good concentric mate. So let's at least start. We know that we are going to need a concentric mate with this face along the inside of the channel, or the opposite face on this side of the channel, one or the other. So I'm going to select that face there and the inside face of this channel, and that sets up that mate relation for us. Now at this point, I need this tapped hole to line up with this hole on my channel. So I suggest anytime you are working with tapped holes, make sure to select the concentric mate. If you select the concentric mate and then accidentally click on a bad face, it will tell you selected entity is not valid. So you can say, oh, well, let me select this face instead, and you'll see that that's a good face for the concentric mate. At this point, I would also suggest, because we've just got one hole in this tied in, to make sure that you do at least two holes and to make sure they're opposite. You don't want two holes on the same side or at the top or at the bottom. I would suggest doing diagonal holes for your mates. Again, I'm going to select concentric to make sure that I'm getting a good face. And voila. Now, in order to build our chassis, I'd like you to bring the channel or the cross channels at 6 big holes in. So 1, 2, 3, 4, 5, 6. So we want the channel to basically come in at this point, and that's going to be the front and the back too. So your other cross channel should be 6 big holes off of the other end. So the process will be to make the coincident mate first. And once that concentric mate is made, it becomes a little bit more difficult just because it's hard to see the holes on the inside of the channel. But you want to move your channel so that you're lined up 1, 2, 3, 4, 5, and you can see I missed. And then try and again mate your channel holes to the tapped hole of the pattern mount. So I've selected there, concentric mate, and now I can do like this face or even this long curly face on the inside. That's actually an acceptable face inside of a tapped hole as well. So I'll do the 1, and then again shooting for diagonals. I'm going to try and get this upper hole up here. Once I select it, I can see, since the channel becomes transparent now, I can actually see in and see the faces of the pattern mount. And it is concentric. I did forget that time to select concentric, so I had to go back and double check and make sure that that was the type of mate that it gave me. and now I can click on OK. Now I do want you to add the screws to this, but I'll help you by telling you which size we're grabbing. So I go into Insert Components and go into the machine screw area, and we're going to grab some 1/4 inch screws and some 375 screws. So the 375 screws are specifically going into the side of these pattern mounts. So I'm going to orient that correctly for that. And then the 1/4 inch screws are going to go from the inside of your channels into the face of the pattern mounts. So these screws here. So again, I'm going to use the Y to turn that and orient that correctly. Now let me just show you by going ahead and completing the mates that are needed for this, lining up on this hole, and then lining up with that face of that channel on the shoulder of my screw. Now once I do that, that screw is in there, and I can look inside this hole, and that screw is right there. That is the tip of the screw, and you can see that the threads are still available for another screw. This is what we did in practice in building this chassis. So you will be using the 0.375 screws here on the sides, and of course I need to mate that shoulder. And you'll be using 0.25 screws inside there. We want 1, 2, 3, 4 on the side, and we want 1 in each corner, so 4 on the inside as well. And again, when you complete, it will look something like this build right here. Now I do not have all the screws in place, but yours will. I'll be excited to see everybody's final project, and we will continue to use this. So when you have finished building this, make sure you go through a file, save. And if you go through a save as, save it underneath Lord of the Bricks 2018 and pre-pinned your name to the beginning. So for instance, Antonio would be Antonio Chassis, something like that, so that we know specifically whose it is, and then save, and I'll have you upload them to the Google Drive area, and I can take a look at them that way, or during Thursday night session I can come in and look at them there as well. I think that's it, guys. Have fun.